Hello, this is my presentation over my project, Trends in Student Performance. This data set is from Kaggle. It's called Student Performance in Exams. It's created by this person. I can't pronounce their name, so I won't try. Originally had 8 columns, 3 continuous, 5 categorical. Uh, but we added one more column. So if I could remember correctly, uh, there's 3 scores that were our continuous scores or continuous columns, which was math score, reading score, writing score. We add those 3 together, divided by 3, which is total, and rounded it up to make it a an int, and called it overall score. Um, EDA was done in Python code, and then found the results in Power BI. So first thing we ran was our EDA was correlation. So we looked to see which of the scores correlated with each other the most, and we could see at 0.95 that reading and writing correlated the most, the closest. I also have a heat map with a mask to make it only uh, half of a heat map. Just trying to get rid of some clutter with that. So it's a small heat map. So we have some more little plots that I like to look at. Have a violin plot looking at overall score to uh, differentiate between standard lunch and free or reduced lunch. A box and whisker plot that will look at each one of the parent um, education status and compare that to math scores. And then I decided to look at a little histogram and have a little have a little trend line, seeing what the trend line would look like on those histograms. So, uh, yeah, so we decided to, after looking at those, make a hypothesis. One among students with an overall passing grade of 70 or higher. Those that receive a standard lunch will represent a greater portion of the passing students than those receiving free or reduced lunch. 2, students whose parents hold a bachelor's degree or a higher degree will perform better than students whose parents who hold a lesser formal education status. And 3, reading and writing scores will demonstrate the strongest positive correlation on a chart or on a graph compared to all combinations. So hypothesis 1, we decided to make a donut chart, and we can see that the hypothesis is true. Now, something I wish I looked back on and really kind of thought about when doing this hypothesis was that there was an overwhelming amount of students that got a standard lunch. So if I probably took a sample and just look at some more different samples and see, is this a consistent trend? Then maybe I feel like it'd be a little more fair approach to this though. But based on how I did it, the hypothesis is true. So hypothesis 2, this was our comparing parent education status. Uh, the top one is an area chart. It has each one of these stacked on top of each other so we can kind of see. And I decided that it should actually be rejected. Now, as you can see in the area chart, right, or even little charts below, that it's relatively true that students that have parents with a master's or bachelor's degree will actually perform better. But if you look at the math, I don't believe that, I don't believe it's too much of a gap, at least between associate's degree, to say, oh yeah, that it's completely true. So I'm going ahead and reject it. But if we decide to do an alternate hypothesis, I believe that we will see some difference between parents who have any amounts of college experience compared to parents that don't. So this is where an alternate hypothesis could be formed. And for number three, this is where we're looking at correlations between all of um, the different subjects. Now we can see here that the tightest correlation right here is between reading and writing, reflecting on what we see on the heat map. Writing scores, math scores, is the weakest one. Math and reading, it's also pretty weak. So now we're seeing that writing and reading have very close, they're very close to each other when it comes to scores. So maybe a child who struggles in reading will struggle in writing. So putting those two together, if we can get a student who's struggling in one of those, get a get a child to be strong in both one of those courses, be strong in the other one most likely. So working on that is very important. Uh, yeah, and I put here any tighter cluster is a correlation closer to one. So you want it to be almost exactly on line, and seeing it closer to a correlation of one. Um, some future work. I want to address some columns that I didn't address uh, in this report. Kind of see how how much deeper you can dive into this data set and find some more fruits that you could bite on to, you know, learn some more from this data. And then maybe some linear regression modeling stuff, you know, maybe doing some tests and some training to see how accurate we can get a model to perhaps be predicting like scores for some like certain situations with some like different columns, right? Maybe we can put some columns together like, okay, well, based on this and this, okay, we can predict that a that the scores will come out to be like this. So maybe some modeling and possibly some prediction in the future be something fun to do with this. But that is it. That's the end of this little presentation.